Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you through every problem in the Chapter 2 test review. And as always, my disclaimer is don't just come to the video and copy down the answers. You need to work out these problems yourself and then come back to the video and check your answers just to make sure you clear up any misunderstandings or problems that you may have gotten incorrect. So let me start off here with my tradition is just a little something here just to let you guys take a look at. It's a beautiful little ceramic symbol here. It's like a Clemson tiger paw for the University of Clemson. Yes. All right, so let's jump right into our test review. Number one, give me two lines that are parallel to plane FGHI. So I would encourage you guys to color code these things, bring magic markers, crayons, colored pencils, whatever to the test. So we got plane FGHI. Okay, so we got the top plane here. So I'm going to darken the top of my box, my rectangular prism. I need two lines that are parallel to that plane. So I need two lines that are parallel to, say, GI. So you could give me MK, you could give me LJ, any of those work. You could also give me lines, go ahead and write these down real quick. So you could give me MK and LJ. Okay, LJ, and you need to remember to put the little line over the top so we know those are line segments. You could also give me the lines that are going this way. So you could give me JK and you could give me LM. Basically, if you just look at the plane that's parallel to plane FGHI, that's the top of the box. So the plane on the bottom is the bottom of the box. So you just need to give me the lines that form that plane down below. So MK, LJ work. You could give me LM and JK. The lines that are going this way across along the bottom, those would be parallel to the plane. Give me two lines that are parallel to HL. HL, let's draw this one, color code this one in red. So I need to give any lines that are vertical, that are parallel to HL. That would be IM, that works, or MI. Remember, it doesn't matter the order of the letters when you're talking about a line. GK, that works. And FJ over here works. Okay, and then two lines that are skew to FG. Let's do this in this beautiful orange and purple color combination, which is the best combination on the planet. Okay, so I need a skew line to the orange line. So basically that means you need to give me a line that's not parallel to FG. So that rules out HI, LM, and JK. It can't be parallel to FG, and it can't have the letters F and G in it. Okay, so what would be a line? MK works. MK is not parallel. That works. MK. This line here, LJ, that's not parallel. That works. Okay, what else is not parallel to FG? The vertical lines are not parallel. So IM, that works. This vertical line HL works. And those are the only two. Because remember, it can't have the letters F and G in it. Any of the diagonals work. You could give me diagonal HM. You could give me diagonal IL. Basically, any diagonal that doesn't have the letter F and G in it works. So I'll just write a couple of these down. HM, LI, and of course there are more, but I'll just stop there. Okay, number 4, give me a pair of one pair of same side interior angles. Okay, so remember, same side interior is inside the sandwich. So we've got to be inside, in between here's the buns of my sandwich, bun. So interior is inside the hamburger. And they've got to be on the same side of the transversal. So they either both have to be below or both be above. So in this case, I could say angle 2 and 3. That works. Or I could say angles 6 and 7. Both of those work. All right, number 5, alternate exterior. So now we want to be outside the bun. So my only exterior angles are 1, 8, 4, and 5. And they have to be on opposite sides of the transversal. So 1 and 5, they work. Angle 1 and angle 5. And then put a triangle around those. 8 and 4 are outside the sandwich. And they are on opposite sides of the transversal. Here's our transversal cutting through there. Okay, so that's alternate exterior. I think you guys have a pretty good handle on that. Number 6, identify two pairs of supplementary angles, not including linear or I say linear pairs. Okay, so in other words, don't give me 1 and 3 because they form a straight line. Don't give me 5 and 6. They form a straight line. So the easiest way for me to do this is to use the little trick that I taught you guys, one big and one little. All right, so if these lines are parallel, then we know that 2 obtuse angles are the same, 2 acute angles are congruent, and then one big and one little add up to 180. So I just need any big and little combination. So I could pick angle 1, and I could pick, that's big, I could pick angle 7. Okay, those are supplementary. Angle 1 and angle 7. You could give me angle 3, that's in a small angle, and you can give me angle 5. I just need one big and one little that aren't a linear pair. 6 and then any other big one. I'll choose 4, 6 and 4. One big and one little. 2 and 8. 2 is acute, 8 is obtuse. So those are going to be supplementary. Any of those work? All right, number 7, if the measure of angle 8 is 125, so this guy down here, that's a big obtuse angle, is 125, and measure of angle 1 is 5x. Okay. All right, so we know that the lines are parallel because they have these arrows down here, and if they're parallel, that means all the big ones are the same, all the little ones are the same, one big, one little, add up to 180. Angle 1 is big, it's obtuse. That is a big angle. Angle 8, 125, that is a big angle. That's a big obtuse angle. So these two guys are the same. So 5x and 125 are the exact same. So I simply set them equal to each other. Divide by 5, solve for x, I get 25. If 5x was big and another angle was little, then I would say 5x plus the other acute angle and then set that equal to 180. But in this case, they're both obtuse, so we set them equal to each other. Number 8, which theorem or postulate proves that the lines are parallel? When you see this on the test, what is that magical word? It starts with a C and ends with onverse. Converse. I must throw that magical word in there when I'm trying to show that the lines are parallel. Okay, so in this case, they give me a little arc here, a little single arc there, and a little single arc here. That means these two angles are identical, they're congruent. And what do you call these angles? All right, remember, one's outside the sandwich and one is inside. So when one is outside and one is inside, the only thing it can be is corresponding. Are they in the same spot in the window? Yes, they are. If you draw your little box, they're both in the top right of the box. So those are corresponding angles. So I would say the converse of the corresponding angles theorem allows me to say that those two lines are indeed parallel. Okay. Number 9 says, what's the value of y that will make the lines parallel? Okay. Well, here, I'll do this again in this beautiful orange color. Down here, this angle, it's kind of hard to see now. I'll put a little orange arc right there. That's the y minus 10, and this is the 100. Okay. Again, these are both in the bottom right of the box. The y minus 10 is in the bottom right. The 100's in the bottom right. So once again, these are corresponding angles. Y minus 10, that's a big obtuse angle. 100, that's obviously a big obtuse angle, so they're equal to each other. So I'm going to say that y minus 10, I'm going to set that equal to 100, and of course I just add 10 to both sides, and y equals 110 degrees. Okay. Make sure on the test you're reading what the problem's asking for. Maybe they're asking for the variable, maybe they're actually asking you to find the measure of the angle. Okay, so if you get x is 12, then you might have to plug it back in to actually find the measure of the angle. In this case, then y is 110, and actually y is not 110 degrees. Y is just 110, which is exactly what I was just saying. So y is 110. So if they asked you to find the measure of the angle, you would have to plug this back in. Y 110 minus 10, which is of course 100 degrees, which is the same thing as its counterpart corresponding angle. Okay, number 10, in a triangle, angle 1 is an exterior angle, and angle 2 are the two remote interior angles. Okay, so the biggest advice that I can give you on this one is draw a picture. It sounds like a game show. Always in geometry, it will help you to draw a picture. That can never hurt you. Okay, so I need to draw a triangle, and I need to draw an exterior angle. Okay, so here's my outside angle, angle 1. Sorry, you can't see that. All right, and then it says 2 and 3 are the remote interiors. So remember, Exterior, remote interior, remote control. We're operating the TV on the other side, the opposite wall, the other side of the room. So that means angle 2 has to be here and angle 3 has to be here. Okay, this angle right here, that's nothing. That's just supplementary to 1. Okay, and then it says find the missing angles. All right, so for number 10, it says the measure of angle 2 is 37. Okay, so this guy, I'll just draw a separate picture. Okay, so this guy is, just erase that. That guy's 37 degrees, and then angle 3 is, erase that, is 99 degrees. Okay, our theorem says, exterior angles theorem says the exterior angle is equal to the sum of the two remote interior angles. So I simply just have to add 37 plus 99, and that gives me my exterior angle of 136 degrees. Okay, that makes sense. That's an obtuse angle there. All right, so number 11, we're basically doing the same thing. Let me draw another triangle here real quick. 1 and 2 and 3. And number 11, it says angle 1 is 98, so they're giving us the exterior angle, and then angle 2 is 55. Well, I know that the angle 3 and the 55 have to add up to 98, so I'll just let that be x. X plus 55, the sum of the two remote interior angles, has to add up to, has to be equal to 98. Subtract 55 from both sides, and I get x is equal to 43 degrees, or angle 3, however you want to label it. Okay, so let's go ahead and flip on over to the back. All right, moving right along. Okay, so it says for exercises 1 through 3, suppose that A and B are parallel and C and D are parallel. So these guys are parallel, and of course I'll put double arrows to notate those guys are parallel. All right, angle 2 and angle 10 are what kind of angles? Angle 2 and angle 10. If I draw my window, 10 is in the top right of the box, 2 is in the top right of the box. So those are going to be corresponding angles. Okay. 3 and angle 3, and what angle are alternate interior angles? Okay, so here's angle 3. Alternate interior means it needs to be inside the sandwich. So maybe it'll help you if you rotate the drawing, the image. Here's 3, and remember the little trick that I taught you guys. Look for the Z. Okay, that's a kind of weird looking Z, but there's the Z. In the crevice of the Z are your alternate interior angles. So 3 and angle 7 are going to be inside the sandwich and on opposite sides of the transversal. So angle 7 is alternate interior to 3. 9 and 8 are what kind of angles? Okay, 9 and 8. Again, if I'm thinking this is the bun of the sandwich, this is the bun of the sandwich, 9 and 8 are inside the hamburger. So they're both interior, and 8 and 9 are both on the left side of the transversal, the railroad tracks. So that's going to be same side interior angles. Same side interior angles. Okay. Number 4, which angle could you show is congruent to angle 11 to prove that lines A and B are parallel? Okay, so I want to figure out if A and B are parallel. All right, so look at angle 11. This is a little trick that I taught you guys. Figure out which line has nothing to do with angle 11. Okay, and I'm looking at parallel lines A and B. So is it C or is it D is the one I can take away? I can't take away D because that affects angle 11. So I can I'm not going to scribble this out because I don't want to make a mess of my drawing here. But on your test and with your pencil and pen, I would literally scratch out line C. Just do away with it. You don't even need that for this problem because it's asking which angle could you show is congruent to angle 11 to prove A and B are parallel. Okay, so again, if I want to turn my paper here and look at these angles, angle 11 and angle 9 are both congruent. Okay, so if you tell me that those were congruent, then I could say, yes, line A and B would be parallel by the converse of the corresponding angles theorem. 11 is in the top left of my box, 9 is in the top left of my box. Or, if you don't turn your paper, 11 is in the top left of the box, and 9 is in the top left of the box. Okay, so those are going to be corresponding. So I would say, if you tell me the angle 9 and angle 11 are congruent, then I could say A and B are parallel by the converse of the corresponding angles theorem. Okay, number 5, what relationship between 6 and 11 shows that C and D are parallel? Okay, C and D. So which line has nothing to do with angles 6 and 11? Which one could I take away? Okay, I could take away line A. Okay, so I'll put up here, I'll put in parentheses, ignore line C for number 5, and then I'll put up here, ignore line A for number 5. We don't need line A. I can scribble that out, and it has nothing to do with angles 6 and 11. Okay, so in order for 6 and 11 to show that C and D are parallel, 6 is inside the sandwich, 11 is inside the sandwich. So they're interior, and they're both on the left of the railroad tracks, left of the transversal. So I would say that angle 6 plus angle 11 has to equal 180 degrees. They would have to be same side interior angles that are supplementary. That have to add up to 180 degrees for C and D to be parallel. Okay, 6 through 10, it says, again, suppose A and B are parallel and C and D are parallel. If angle 6 equals 50 degrees, and actually I'm gonna redraw this real quick just because I've drawn on top of my diagram. C, D, A, B, parallel, 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 parallel. Okay, if angle 6, which is right up here, so if angle 6, if this guy is 50 degrees, find the measure of angle 11. Angle 11 was right here, so angle 11 would be down here. Okay, if they're parallel, that means this one's little. Okay, so I'll put little. Angle 50 is little. That's a small acute angle. Angle 11, is that little or big? That's obtuse, so that's big. Whenever you have one little and one big, they have to add up to 180 degrees. So I would do 180 minus the 50. That means the angle 11 has to be 130 degrees. Okay. Measure of angle 2 up here. This one's 2. If this guy is 70 degrees, okay, what is the measure of angle 6? Okay, angle 6 was right here, so I'm going to have to kind of scratch that out, say 6 here. Okay, 7, is that big or little? That's small, that's less than 90, so that's little. That's an acute angle. What is 6? We were just here just a second ago. 6 is little, okay? That's a small acute angle. So if they're both little, if they're both acute, that means they have to be equal to each other. So if that's 70 degrees, then that has to be 70 degrees. Measure of angle 6. Okay, let's say that measure angle 1 is 130. This big obtuse angle is 130. Find the measure of angle 5, which was over here. Here's 5. 130, big or little? Big, greater than 90. 5, big or little? That's big. That's greater than 90 degrees. That's an obtuse angle. So they're both big. So that means they both have to be the same. So if number 1 is 130, then number 5 has to be 130 degrees. They're congruent to each other. Number 9, if angle 7, that was this guy here. If angle 7 is 110, okay, find the measure of angle 10. 7 was right here. Angle 10 is right below it. So this is angle 10. Okay, 110, is that big or little? That's a big obtuse angle, so that's big. Angle 10, is that big or little? This is little. That's acute angle. So when I have one big and one little, sounds like a broken record, they have to add up to 180. So I just do 180 minus the big obtuse angle, 110, and that gives me 70 degrees for the measure of angle 10. All right, last one of these. If angle 4, which was up here, if this angle is 45 degrees, okay, find the measure of angle 12, which is this guy down here. Here's 12. 45, big or little? That's little. These, by the way, these two angles were same side interior angles. This is 45, that's small, that's acute. Angle 12, that's small and acute. They're both little. So that means they have to be equal to each other. What's the name of that? This is outside the sandwich. This is inside the sandwich. These are corresponding windows, corresponding angles in the top right of the window. So they're going to be congruent. So angle 12 is also going to be 45 degrees. Okay. All right, now we're going to finish up here with some algebra. All right. Find the values of the variables. I got an x and I got a z. Well, let's think about it. Z, that's pretty easy. These two guys form a straight line. Anytime I have two angles that form a straight line, 1 and 2, they have to add up to 180. So to find Z, I'm just going to do 180 minus this exterior angle, and Z is going to be equal to 30 degrees. And that's pretty easy. If Z, so I'll put a 30 in here. Okay. Now I know that, I'll scratch out the Z. All right, now I know that these three angles have to add up to what? 180, right? Three angles of any triangle add up to 180. So I know this guy, X, that guy, plus this guy, X plus 20, plus the 30 that I just found, all three of those have to add up to 180 degrees. Okay, and now I'll just solve. X plus X, that's 2X. 20 plus 30 is 50, equals 180. Subtract 50, both sides. 2X equals 130. Divide by 2, and X equals 65. As always, guys, go back. For sake of time on this video, I'm not going to go back and plug each one back in. Plug it back in, plug 65 back in, and make sure that all three of them do indeed add up to 180. Okay, number 12, same thing here. These two form a linear pair. They form a straight line, so I'll just do 180 minus the 140. So X is going to be equal to 40 degrees. So scratch that out, put in a 40. And then I know the three angles add up to 180. What does that little box mean? That little box means that they're 90-degree right angles. Okay, so I'm going to do 180 minus the 40 that we just solved, minus the 90 here, the right angle, and Y is going to be equal to 50 degrees. Go back and check. This is a right triangle. 50 plus 40 is 90. 90 plus 90, yep, they both add up to 180. That's correct. Okay, number 13. Sorry, that's a little small. Maybe I can just blow this up just a little bit. Okay. We got X and Y here. Okay, so this angle is 39, this angle is 49. Now there are a couple of different ways you can do this. To find X first, yes, I could just go ahead and do 180 minus 39 minus 49 and get X, which, let's go ahead and do that. That's one way to do it. X equals 180 minus 39 minus 49, and that comes out to be 92 degrees. And then, so if this guy is 92, then I know these guys form a linear pair, so I just do 180 minus 92, and Y is going to be equal to 88 degrees. Okay, the other way you could have solved it is using the remote interior angles. If that's 39 and that's 49, then to get the exterior angle, you just add those together. 39 plus 49 adds up to 88. So that's a different way you could have gotten Y. And then to find X, again, you would do the supplementary thing. Or find X by doing what we did the first time. Add those two angles together and subtract them from 180 to find the missing third angle. That's why I love math. There's several different ways to get the right answer a lot of times. Whichever one you're more comfortable with. 14. Whoa, I got a lot of stuff going on here. 14. Blow that up a little bit more. All right, so I got 15 for an exterior angle. I've got 84 right there. I've got a W, a Y, a Z, an X. Goodness gracious, got a lot of stuff going on here. Well, here's an X. Okay, we learned this back in chapter 1. What do you call angles that are across from each other in an X? Angles 1 and 2. Those are vertical angles. They're across from each other. So they're going to be congruent. So if this guy is 15, what is Z? Z is across from it, so Z is also going to be 115 degrees, vertical angles. 115 and X form a linear pair. They form a straight line, so X is going to be equal to 180 minus the 115. So X is going to be equal to 65 degrees. Okay. If that guy is 65, what is Y? They're vertical angles. They're across from each other in the X. So Y is also going to be 65 degrees. Okay. So now I'll scratch out the Y. I'll put a 65 in here. If that's 65 and this inside angle is 84, then I can find the W by adding these two together and subtracting from 180. So W is simply going to be 180 minus the 65 minus the 84, and W is going to be equal to 31 degrees. Hopefully you guys were able to get that one correct. Okay, number 15. Find the measures of angles 1 and 2. Zoom back out here just real quick. Okay, angles 1 and 2. Alright, well, I can't use 3 angles of a triangle here because I only have 1. I have to have 2 of the 3 angles to use the triangle sum theorem. All 3 angles add up to 180. So that means I'm going to have to use this outside angle 95. These two are supplementary. They form a linear pair. So angle 2 is going to be equal to 180 minus 95. So angle 2 is going to be equal to 85. Okay, so if this guy is 85, now I can use the 3 angles of a triangle. That plus that, and subtract that from 180 gives me the third missing angle. So angle 1 is going to be 180 minus that 85 that we just found, minus the 40, this guy down here. So angle 1 is going to be equal to 55 degrees. Of course, go back and plug these back in and make sure that everything adds up to what it's supposed to add up to. Alright, let's go ahead. I'll come back to 16 and 18. Let's go ahead and skip on down to 17. Okay, here we go. Vertical angles. If this is 40 and the lines are parallel, how do I know that? Because I have an extra set of arrows right there. Alright, so these two guys are vertical angles. They're across from each other, so the measure of angle 1 is also going to be 48 degrees. And then what do you call angle 1 and angle 2? This theorem actually technically is not in our book, but it is one of our angle pairs. These are same side exterior. 1 is outside the sandwich, 2 is outside the sandwich. Here's my hamburger. They're outside the hamburger, and they're both on the same side of the transversal. So these are same side exterior angles. And we know that they're supplementary. Or you can use Mr. Manise's trick that I taught you. 1, is that big or little? 1 is 48, so that's a small acute angle. Angle 2, is that big or little? That's a large obtuse angle, so those two angles are not going to be congruent. When I have one little and one big, they have to add up to 180. So I'll simply do 180 minus the 48, and angle 2 is going to be equal to 132 degrees. Okay. Little, big. Got to be supplementary when the lines are parallel. Okay, number 16. Number 16. Find the values of angles 1 and 2. Okay, well, this one maybe is a little bit easier if you turn it sideways like this. These lines are parallel, which means all of my corresponding alternate tier, all that stuff comes into play. All right, but here is a common mistake that I see. You got to know that these lines here, I'll draw these in a beautiful orange color. These lines here, they're not necessarily parallel, okay? They kind of look parallel, but actually to me they don't even look parallel, and we can't go based on our eyeballs anyway. I don't have any arrows on the orange lines, so I can't say that all the big ones are the same and all the little ones are the same, because these are two completely different transversals. So it's almost like I got to take this problem one side at a time. I only want you to look over here on the left-hand side. If the purple lines are parallel, that's a box, okay? That's a 90-degree angle. And 1 is inside the sandwich. They're same side interior angles, okay? So if this is 90, then angle 1 has to be 90. So angle 1 is also 90 degrees. By the way, this is also our parentheses. That's our perpendicular transversal theorem, which is just a glorified way of saying they're corresponding angles, or they're same side interior angles, when all the angles are 90. Okay, so our perpendicular transversal theorem says when I have a line that cuts through two perpendicular lines, if this purple line is perpendicular to the orange line, it also has to be perpendicular to the other purple line, which means I have to be able to put a box here in angle number 1 as well. All right, now for number 2, again, we got to kind of take this one at a time. We got to only look on the right-hand side because this is a different transversal. 2 is inside, interior, and 80 is interior. So these are also same side interior angles. This is a small acute angle. It's less than 90. 2 is an obtuse angle. We know that same side interior angles are supplementary. So to find angle 2, I'm simply going to say angle 2 is equal to 180 minus this 80 degree angle, and that means that angle 2 is equal to 100 degrees because they are same side interior. Okay, and the very last problem here. Okay, I like this problem. So this is a box. I got to find 1 and I got to find 2. Well, what do we call these angles here? They're vertical. If that's 68, this guy has to be 68. So angle 1 is also 68 degrees. How do I get 2? Well, 2 is vertical to this angle, so let me just put a 3 in here. How do I find, if I find 3, then I find 2. If I want to find 3, then this is just the triangle sum theorem. I got 2 of the 3 angles of my triangles, so to find 3, I'll say angle 3 is equal to 180 minus the 90 degree right angle minus the 68 that we just found. And angle 3 is going to be equal to 22 degrees. Okay, but that's not what they asked us for. They asked us to find 2. If this guy is 22 degrees, then this guy is vertical angles, so angle 2 also has to be 22 degrees, vertical angles. All right, that's it for this video. Hope you guys enjoyed that. I hope you wish you good luck on your test, and we will see you on the next video.